Okay. So in the first example, all I'm going to do is log properties. Okay. So everybody buy this. Right? From the properties of logs. That's the reason why I had you do the worksheet. Okay? So everybody all right there? And now I'm going to differentiate ln AX. I'm going to do it two different ways. I know that this is equal to this. So in order to differentiate this box, it's the same thing as differentiating this box. Now, is A a constant or not? Yes. Is ln A a constant or not? Why not? It's not. Okay, so is 2 a constant? Is ln 2 is constant? Are you going to get more than one number for that? Is it the same? Make up your mind. You can't sit on the fence, okay? Don't be dissy, okay? Yeah. Is it a constant or not?
Yes.
It is. It's the same freaking number if you go to the other wing. It doesn't change. Okay, you go to the other side of the earth, it's still the same thing. You go on the moon, it's still the same number. Okay, so it's a constant. What's the derivative of a constant?
0.
Thank you. Do you know how hard it was for period 1? It took me literally 5 minutes of joking around to come to the answer. Thank you, Taddy. I appreciate that. Okay, so if I differentiate this, Taddy tells me the derivative of this is a 0. From yesterday, we learned what the derivative of ln x was.
1.
Okay, it's going to be the same performance as period 1. 5 minutes of joking around to get the answer. Thank you, Layla. 1 over x. Thank you, Layla. You saved my life. Thank you. Well, you saved yourselves from corny jokes, actually, is what it is. Okay, 1 over x. Okay, guys, got this from yesterday. Derivative of ln, Monica, Chupkar, otherwise there's more yelling going on here. No sprechen Sie Deutsch, no sprechen Sie. Bitte, no sprechen Sie. She understands what I said. So that don't speak. That was German. No, that was German, right? Sprechen Sie Deutsch? Yeah? Yeah. Okay. Okay, listen up. Carry. Sorry? Oh my good Lord. Wait a minute. This is from yesterday.
Okay, and I don't get what we're doing, so I'm asking you to tell me.
But if you did this yesterday, then you should know the answer.
Do you know what's going on and don't get this?
Okay. Do you get it now, sweetie? Did you get it now? You okay? Derivative of ln x is 1 over x. Okay? All right. So that's what this whole lesson is based on that derivative. That's all. Okay, that's all. Okay, coming back down to where we are. So I did this in one way and then I'm going to do it in another way, okay? All right? And I'm going to change colors here so you guys can keep track of it. So the first way I did it was by expanding this ln function. Okay, like here, like this. All right, Monica. Now I'm going to do it a different way, okay? First of all, do you all agree that the derivative of an ln something is 1 over something? Okay, so then this is going to be 1 over ax. Then I'm going to use the chain rule. Okay, and I'm going to multiply it by the derivative of this inside stuff. What's the derivative of ax? Can you be loud so that you can drown those guys there at the back? Johanna, loud and clear. A! The derivative of ax is a. Rule number 1, 6 months ago. The top rule right here. The top rule right there. Okay, 6 months ago. All right, so you're going to multiply this by a. What do you get? What do you get? No, that was an a. That was actually a painful. Ah, it hurts. 1 over x. Same stuff that we got earlier. Guys, with me on that? Okay, so if you use the properties of logs, things will be easy. No guarantee that you can always use the properties of logs. For example, if you are differentiating this stuff, there are no properties of logs that would come and help you out with this. There aren't any. So you'd have to do it the long way. Right? It's going to become 1 over x plus root x plus 2, and then the derivative of whatever this is. Okay? So you guys are going to be doing lots of problems like that. 2 more examples and then 2 for you. Okay? So 4 that I do, because I work hard, and 2 you do. Okay, ln root x plus 1. Use properties of logs to simplify that first. Yeah, Leah? Anybody? Okay, so that'll be just rewriting this, but you need to take another step beyond that. What happens to the half? Sorry? Thank you. Thank you. Finally, she's getting stuff. Okay, it comes to the front. Okay, so now we're going to differentiate it in 2 ways. We're going to differentiate this thing here first. Okay, so the half stays because that's a constant. And what's the derivative of ln x plus 1?
1 over x plus 1.
Thank you. Okay, guys, with me on that? So that's one way, and now the other way. So to differentiate this, you're going to use the chain rule. So first of all, this is going to become 1 over square root of x plus 1, right? Because the derivative of ln something is 1 over something times the derivative of the inside. So the inside is this guy here. What's the derivative of square root of x plus 1?
1/2.
Nice, good job. Man, she's on a roll today. Whoa, what?
To the power negative 2.
Oh, negative what? Can I come and give you a hug for that? At least give you a high five? Now, can you do that all the time? Every time? Every day?
I was gonna hug.
I'm not allowed to hug. Ha ha. Okay, what do I do with this now? Okay, what happens to this x plus 1 to the minus a half? It goes downstairs because it's got a negative exponent. So you get 1 over square root of x plus 1. And what happens to the 2 square roots? Well, cancel, but give you what? Just x plus 1. Okay, the square roots go away. Okay, so then this becomes 1 over 2 x plus 1, which is exactly the same thing that we got earlier. Okay, but you can see how the second method is painful. Okay, and the rules of logs come in and help you. Some problems they will and some they won't, so that's life. Okay, you guys with me on this? Okay, last 2 problems for you to do, and then we are done. Both ways, okay, both ways.